Hello everyone, welcome to my channel Cloud and Data with Koshi. So we already have discussed the data manipulation and data visualization of the customer churn analysis, this project, right? So now today we are going to create some models, and as per the task they have given some different kind of models we have to create. Okay, so we will discuss these things. So please let me know, am I audible or not? Okay, I hope I am clearly audible to all of you. And now let's move to the task, and then we are going to implement these all of the tasks and step by step. So we are already in my task page. I hope everybody can see my page. And so first task is the linear regression. So what the task? We have to build a simple linear model where dependent variable is your monthly charge and independent variable is tenure. So there is two concepts. One is dependent variable, another is independent variable. So here they have clearly mentioned that monthly charges, there is the dependent variable and independent variable is tenure. And the concept regarding dependent variable, independent variable, that linear regression model, I have already discussed this concept in the the earlier sessions. So I have add this link also, so you can go through that, how you have to create that dependent and independent variable, how we are going to create that models. And now I'm going to implement the same thing in our customer churn analysis dataset. And here the task is that we have to divide the dataset into train and test. That is 70% is training data, 30% is your test data. And I have to build the model on train set and predict the values on test set. That is pretty straightforward task that has been given. And after predicting these values, find the root mean square error. So let's go and let's try to implement this all the concept in our customer churn analysis. So I'm going to move towards my Jupyter notebook, and I hope that you can see my Jupyter notebook page. That already we have the earlier session we have completed the data visualization part up to that, and now we are going to create the machine learning model. I'm going to add the heading machine instead of code, that I have to change it to, you can see if you want to write the markdown, if you want to create the headings, then you should go to the markdown cell. So I have changed the cell type, and here I'm going to write this machine learning algorithms, algo, and that is your first algorithm is linear regression model. Linear regression model. Okay, I hope you can see the screen. And now, so in order to implement the machine learning model, first we have to import. We have to import that linear models. So any ML model over here in the Python we have implemented, we're going to implement. So we have to use that sklearn library. Okay. So you can go and search that your sklearn library, and you probably get this. You can write sklearn, and you can see the screen scikit-learn machine learning in Python. So sklearn, you can write linear regression. Linear regression, just search in that Google bar that sklearn linear regression. So you can get this kind of link. You can directly redirect to the page to the linear regression model. And I'm going to be this linear regression model. You can see in each and every step they have given that how we can implement. They have also provided some code snippet over there that we have to add this one. So we have to they've given some examples with the NumPy, that with the NumPy library with some static data. They have created the NP array and trying to implement that linear regression model. So you can go through this examples page and that linear regression model page, you get the idea. So everything is given in this particular official link of scikit-learn, that I will also add this link to my description box, so you can get the idea over there. So in order to implement that, we have to write these things. Just go over there and you can write from sklearn, and you have to import linear model. Okay. So you can also go and search linear model over there. Just sklearn linear models. The next link probably you can get, and linear models. So you can see sklearn input linear model. I have to input this one. This line you can take from sklearn input linear model. Same I am also writing. And now we have to import sklearn, and from that sklearn.linear model, sklearn.linear, I'm writing linear model, and we have to import what I'm going to import, linear regression. One more thing you have to keep in mind, that linear regression, every model name that should be in camel casing, right? So you can go over there and you can go search that linear regression. Same thing I'm going to implement sklearn linear model. So class, you can see sklearn.linear model. This is the main class, and from this class we have derived this linear regression model. This constructor that I'm going to add. So import your linear regression. Okay. So this is my basic library. First, you have to use the linear model. You have to import the linear model. Once you have the linear model, then you can import that your, and now the third libraries that I'm going to add in that algorithm, that is your train test plate. Why I'm going to use? Because whenever you're going to create the model, right? So it needs two things, and that is the training data set, and you need some testing data set. So here it clearly mentioned that in the test set, they have to keep 30% data. So you have to keep aside 30% test data, and you have to train your model on the 70% data. That is the label, the scene data, right? And on the basis of scene data, the model will be trained, and we can going to predict on my remaining 30% data set. So everything is given in that machine learning algorithm, that you have to input your 10 test split. Everything is just you have to call this. There is no any hard and fast rule. You have to call this 10 test split, and you can create this model, right? And next we have to import, you can write from, and you can notice that everything I'm going to import sklearn class, right? So from sklearn, you have to import your linear model. From sklearn.linear model, you have to import your linear regression. And now I'm going to use from sklearn.model selection. So you have this model selection, and you have to import your, what I'm going to import, train test split. Just write train underscore test underscore split. Okay. So in order to divide the data set, train and test split. Okay. And before going to implement this thing, we need the target and the dependent and independent variable. So here we can see our we just see that your dependent variable is your monthly charges, and your independent variable is tenure. Okay. So just first you have to execute this cell in order to establish all the dependency libraries, all the test split. Okay. Just press Ctrl Enter and you can see something is showing star and busy, and now the cell is written. So there is no issues. Your linear model, linear regression that has been inputted properly, right? The next task you have to this is the identification. Your dependent variable is your monthly charge and your independent variable is tenure, right? So just I'm going to write over there the dependent variable is my monthly charge. So from where I will get my dependent this monthly charges, right? So if you remember, our main data set is what? Customer churn, right? Here, this is my data frame, customer churn. Inside the customer churn, if I just going to explore the columns, and you can see this is my monthly charges. This is my dependent variable. And this is my dependent and independent variable is tenure. So tenure is dependent on the monthly charge. How the tenure will be there, that is dependent on this monthly charge. Only one variable, right? Monthly charge. Whenever you are going to implement these things with multiple, then multiple regression will be coming. But this is only one variable. Dependent variable is one. Independent variable is one. So monthly charges. So you can also see the data. If I can write customer underscore churn, and I just going to see this monthly charges. Okay. And you can probably see this is the data. And this data set I have to keep kept as a Y. So Y and X. X my training data and Y is my test data, right? So you can use that Y is equal to your customer churn. You can take the customer churn and this is your columns, monthly charges, and you just write, and you can add this one and also extract the tenure column same way, like you can see I'm extracting the tenure column and then column in that X. So here I have to use that customer churn, and you have this sub data set that is your tenure. You can see the two data set we can see, and if you want to explore this extracting data like customer churn, you can see the customer churn and you can see a tenure. Okay, and now this is my customer churn data, right? And now I have my Y and X. So I'm just also writing extracting the data from monthly charges and add it inside Y variable. Just follow these things and you easily can understood. So we can write extract, just writing extracting the data monthly charges column. This is your column name. Okay, the data from tenure column and added inside the X variable. Pretty easy, and already we have to execute this cell, and now I'm going to see this data. You already seen this data, right? First, I just want to add, yes, right, Y dot head, and also you can write X dot head. Okay, and your these two data set you can explore, right? Monthly charges, the first 5 rows, and tenure, the first 5 rows data we can see. The steps, what we are going to prepare as of now, we have to import our linear regression model, we have to import our train test split, and now we have to divide the data. That is, one is your monthly charges, is your, you can say, monthly charges in my dependent variable. So identify these things. Monthly charges is my dependent variable. So just copy. You can also write these things. Just you can write, that's my dependent variable, and that is my independent variable. Okay, independent variable. I hope you can understand as of now. Next part, we have to split. So we have to divide the data in data split. Now I'll just write, now we have to split, and you can also take these things, divide the data set in your 70 and 30 ratio, right? Just copy, and you can go over there. You can just paste, divide the data set into train and test set, right? So you have the train underscore test underscore split. Okay, you already input these things, train test split, in your Jupyter notebook, right? You have to import from the scikit-learn. This is your model selection. You have to import this train underscore test underscore split. Okay. And now we're just going to add. So we can write train test split, and you have to pass in x as the first parameters with the features that will be stored in the x, and that will be going to the first parameter. And the target level, what is my target level? That is monthly charges, right? And that is y. And we have to provide the test size, and we have to use test size, that is your 30%, 0.30, and add the random state for random state. Okay, and so test size is 0.30. You have to provide 4 parameters over there in the train test split. Okay, and you can see that x, I have to provide that x value. X is nothing but your tenure, and that is your independent variable. Now we have to provide that y, and that is your monthly charges. And when you pass two data, you have to pass two extra all parameters. That is your test size, that is your 30% data you have to keep for the testing purpose, and random state is your random state is your 0, right? So my question is that what is the concept of random state, right? Why I'm going to add this random state over here? Okay. So I'm just going to add this line so you can also understand the concept of random state. I'm just going to add in machine learning the term random state, okay, refers, which can be, that is refers to the seed value, okay, used by number generators, right? So it's a seed value. Every time your value should be randomly changed. So we have to keep this value as a 0, right? So I'm going to write refers to the seed value, and this seed value used by pseudorandom number generators. So many machine learning algorithms involves some element of randomness. Randomness, especially when it comes to initializing parameters. Okay, so just remember these things: initializing parameters, or you can also supply your data. You can also interchange your data, right? Or suppling. So every time this value will be suppling the data. Okay, the random state allows you control this randomness. So random state basically allows you to control this randomness by specifying a seed value. Allows you to control this randomness by specifying a seed value. Okay, and in order to creating the random state, we have to setting a random state, and we can ensure that the result of your ML algorithm are reproducible, right? And if you use the same random state, so you should get the same set of random numbers each time you run your code. You just remember, I also write these things. So settings a random state ensures that the results of your machine learning algorithm are reproducible. Okay? And if we use the same random state, I hope you can see my screen. So if we use the same random state, you should get the same set of random numbers each time when you run the code. So this can be crucial for your debugging purpose, uh, sharing the results, or comparing different models, or comparing different models. As example, so for example, you can also write in Python, a sklearn library, many algorithm and functions have random state, have a random state. Okay, parameters. That you can set to a specific integer is ensure that the randomness so this ensure the randomness is cons consistent across runs if you use the same seed. Okay, so you can see I if I not use the random state. Okay, so what could be the problem, or what could be the change, right? So 30% is going to my test size, and I got my this 10 test split I have provided, right? Now you have to assign the 10 test split, this data, your 4 variables. But before that, if I execute these things, 10 test split, and you can see every time this value being changing, right? This value randomly changing. Now, if I use this constant 0, random state 0, and now I'm going to execute. There is no changing. You can see I'm just execute this cell and your random state will be remain 0. That is the reason the machine learning algorithms, whenever you're going to predict, whenever you're going to split your data, you must ensure that your this value should be 0. Otherwise, randomly the seed will be changing. Every time it will be changing. And that may be provide any kind of issues, right? So better you have to keep the random state is 0, and you can go proceed with these values, right? So I already explored and already discussed when and what is the reason. So you can see random state ensure that the result of your ML algorithm are reproducible. So if you use the same random state, you should get the same set of random numbers each time when you run. So I already shown this thing. If you don't mention the random state, the value in every time new value will be generated whenever they are splitting. So randomly it will supply the data, right? You have to understand the value will be supplied, the data will be supplied each and every time, each and every moment the data will be supplied whenever execute. So we need some fixed data, we need some data, a random state. Every ML algorithm, the random state is there. So we have to use 0 constant. So the value will not be changed. So prediction should be accurate. The model prediction should be accurate. Okay. And now we are going to divide. That is your 4 variables I told x10. Now we can divide it in x10 comma x test for your training. This is your training y test and your y train, and it is your y test and assign. So just copy x train, x test, y train, y test, and assign these things. Or you can you can take other cells. So inside the other cell, you can also do the same thing. So this is your notes, I hope. And now you can add, and now you can write x train and your x test. You can write y train and your y test is equal to you have to assign 10 test, right? So in 4 variables, I have supplied this data and keep that 30%, that is your test size. Now we am interested to see the shape of the data. So we can understood. So just copy extend to see the shape of the data, rows and columns, right? Rows and columns, and for all 4 variables. We can write extend dot shape and you can write x test dot shape and you can write y10 dot shape and you can write y test dot shape. Okay, and now we just see your rows and columns. So 4930 your training data and 30% if we calculate, that is your test data. So if I will calculate, if we calculate the this size, that is your 0.30. So 4930 your training data and your 2113. How much the value? 7023 and 7043 into 30 by 100. That can be your 211, right? So 4930, that means your training set, training underscore data plus your testing underscore data. This is a concept, right? So 2 values we can get. So actual data, if you see, that is your 70343 test and training, and divided, that is your 30%. Okay, so we can we have 30% the data, we have to split it. And extend represent all the values, the features of so extend represent all the independent values, right? Because x10 is my independent. That is your yes, independent. That is a month. Independent is your customer, right? So all the values feature of all the values. In the Indian variables X text also represent training values, all the training values. Training values. Even all the test training values feature or feature of independent variable. And Y10 present all the training values shared of dependent. Because y I in the y you can see in the y we have that monthly charges that is dependent, right? So dependent. Oh, sorry. Dependent variable. And y test represents all the testing values, the feature of dependent variable. Okay, so we have this data, train test split. So we can save, we can also see that rows and columns of the train and test set. Okay, so 4930, and that is your x10, and that is independent variable, and y10, that is your dependent variable, and this is the shape of the data. I hope you can understand. If you have any questions, if you have any doubts, so please let me know in the comment box. So I can definitely address your concern. So next, then next move towards the prediction and creating the models, right? And I just wait 1 minute, and then just within a second we can start. If you have any doubts, so please let me know, and then we can proceed towards that by model creation. Now creating the model. Here I'm right. build the model and predict the value, right? Just copy this task and just add, build the model on train, set and predict. And you can just adding one heading so you can also understand in the later whenever you're going through this lecture. So model building. Okay. First, so 70 and 30 we are going to split, right? So how we can create? We can create the model. And now one question before going to create the model. So my question is that why we divide the data train test split, right? So the code I'm going to write, there is no issues. Just I'm going to explore. These are my questions. Why we divide the data into train and test split. Train and why and divide train and test training, train and test split, right? The reason is that dividing the, I'm also write this. So dividing the data into training and testing sets is a common practice. Common practice in ML to assess how well a model generalize to new and unseen data. Okay, a few points you have to remember. Model evaluation. Okay. So why it is done? So why it is done? First, that I'm going to explore, that I'm going to tell, that is your model evaluation. Okay, evaluation. So this is one point that you have to recognize for that why I'm going to split. So what is the concept of model evaluation? That by splitting the data set into training and test set, right? You can train your model on one subset, okay, and evaluate its performance on another. So this is the model evaluation. You are training on subset of some data, and you can testing, you can evaluate the performance, how it can be accurate, how it can provide the accuracy on that another data. And this provide an estimate of how well the model is likely to perform on new and unseen data. So one point, that is model evaluation, and that is the purpose how it can work on that unseen data. Okay, this is one point that you should consider why divide the data into training and test split. And next, there's preventing overfitting. I'm also write this second point, preventing overfitting. Okay, so if you train a model on the entire data set and then evaluate its performance on the same data, you might get misleading optimistic results. So your model should be biased. So we should not take all the data, okay, and training or provide the training and testing on the same data set. So your model should be biased. It might get the misleading or optimistic result. Okay, it can provide the errors. Okay, the model could memorize the training data. Okay, your model could memorize the training data because your model is seen, your label is given and your model is trained over there, right? And it could memorize the training data rather than the learning the underlying patterns. Okay, it cannot see that unseen data. It cannot recognize what the new data set I'm going to predict, how it can be going to predict. So prevent your overfitting. That is the one point you should consider why we are dividing the data into tens split. And next point that I'm going to add, that is your generalization assessment. Generalization assessment. Okay, the goal of a machine learning model, what is the generalization assessment? That is the goal of machine learning model is to generalize well to new and unseen data. Every time this concept is coming, that unseen data, okay? The testing set simulate the scenario and it allow you to measure how well the model generalize beyond the training data, how your model would well accurate, how your model would provide exact that prediction on the unseen data. That is the reason we have to provide. And this and fourth point that I am telling, that is hyperparameter tuning. Okay, fourth point, that is hyperparameter tuning. Okay, I hope you can see my screen. So hyperparameter tuning. So during your model development, whenever you are going to develop your model, you might adjust hyperparameters to improve performance and accuracy. Okay, the testing set acts as a benchmark to assess the impact of these changes. Okay, and so it's crucial to have a separate validation. We kept it aside 30%. So it's crucial to have a separate validation set for more robust hyperparameter tuning. So 4 point we should remember why we divide the data into train, test, split. And please remember one thing, and I also write these things. So it should be better. You can also understand this thing. So when we splitting the data, it's common to use. For example, 80 by 20 or 30, 70 or 30. So this is the common thing. So generally, we prefer 80% training or 20% testing or 70% training or 30% testing. So with a larger portion allocated to the training data, you can see out of 100, okay? So this is my 100 and this is my also 100. So out of 100, large portion, 70% we can train and 30% we kept aside for that unseen, the new labeling data, right? The exact ratio depends on that ratio, how we can depends. So the exact ratio, we can say it depends on factors, such as size of your data set. So if your data set is so large, Okay, so if your data set is large, then your size, the data set and the specific requirement of the problem, and additionally using these techniques like cross validation, you can use that cross validation techniques can further enhance the evaluation process. Cross validation, okay, it can further enhance the evaluation process by dividing the data into multiple folds. That is different cross validation, that is different concept, and it can fold, it can chunk with some fold the data. So it generally used when the data set is large, whenever we have the large data set, and as per your business requirement, the decision point is coming, how much we can take that training and how much we can going to test, keep aside for the testing purpose. But in general, you can say that 80% your data we must keep aside for your training, the larger part of your entire data set, and 20% we can keep aside for your testing purpose. So you can use that training and testing data, and that is the reason we can say that 4 points we should remember, that model evaluation part and preventing your overfitting and generalizing assessment. So unseen data, how we can prediction, main concept is that we have to test the data on the unseen level and some hyperparameter tuning. So these all the reasons, that for main reason we can say that we can divide the data into 10 split, right? And now the time is come to create the model. So right, you have you are in the exam, right? So you have given 100 exercise, and you learn all the 100 exercise, and you are come to test. Then out of 100 exercise, they have given 30%. Okay, and this test page that we can completely new. Okay, you cannot see whenever you prepare your exam, right? So you prepare your exam, and that time you can learn each and every concept. You can learn the last minute suggestion, and you can understand the concept and you can prepare. But when you actual appear for the test, so the questions might be different. Question might be new. The same question they can be asked in different ways. So that is your new. So assume that you are model and you have to learn all concept from your textbook, right? And now you have to, now I am going to test you how you can learn. Now I am going to evaluate you. Now I am going to test your ability, how you can appear and how you can give the out your good exams, right? So that is the reason we can say, and when you appear for in a new exam, that your questions will be different. The same question they will be asked different way. So you are unseen. You don't know which questions will come your exam purpose. You don't know. You don't know actually the result. So that will come, and you have to prepare and you have to perform on that. That is the reason we have to treat that test set. Completely different test set, right? Okay. So also remember that preventing overfitting concept is that only uh, I only training the data on the 100% data, right? We are not going to keep aside 30%. So when it tests the same data, it will provide accurate result. But whenever the data set is new, it will provide completely errors. It will not predict, because testing is not there. 100% they have to training. So new set of data whenever I provide to my model, that is totally new training. He does not acquire the training, right? And that time it provide errors, because that is the so we have to prevent the overfitting of the model. The model will be biased. Only provide accuracy on that which data they are going to predict, which data they are going to test or training. The same data we should not same entire data set if you provide the training, only those data set the model will be perform good, accuracy will come. But the data set is new, that model, the label is unseen. They cannot see the data. That time model should not prepare well, and it should not provide the accuracy and should not creating that actual accurate model, accurate prediction. Okay. And that is the reason I already told we have divided data into your train and test split. Now we have to first creating the model, we have to initialize that constructor of the model, right? So we can write regression model. How we can create the initializing, how we have to initialize the model. So you have, if you see, you have 1 minute, yes, so you have the linear regression. In your sklearn.linear model, you already import the linear regression. So copy this linear regression and you have to initialized. So you have to initialize the model constructor and create the object of this linear regression. Okay. Your model will be created, just press Ctrl Enter and your regression model will be created. Now, next, and we have to also check the type. What is the type? You can write type, you can add regression model. And if you notice, they will provide sklearn.linear_model.base linear regression. So your underlying structure is your linear regression. Your model will provide it, right? So this is your regression model. The type is sklearn.linear_model._base.linear regression. Okay, now I am going to feed the data. Now I am going to feed the data. How we can feed? So just copy the regression model because it represents your linear regression, and you can just write feed. Okay. You see, if you write zip tab, na, so you can see the signature. Just press shift plus tab. Every definition signature of the model there. So regression model, press shift tab. And you can see type linear regression starting from file, and this is your entire documentation. So doc string, ordinary, least square linear regression. Linear regression fits a linear model with coefficient to minimize the residual sum square. And if you just call down the parameters, the normalization, the copy, end jobs, everything is given. Coefficient, rank, so everything is given. If you just wanted to explore the definition from where that model is coming, and also they have provided the doc string, the definition part, parameters, rank, everything they have given, coefficient, how the model can be expressed well, these all the definition, all that things they have provided. Okay, so in the Jupyter notebook, na, you have to paste, like I have in the feed. I cannot understand what is the feed. Just write regression model dot feed. Just press the cursor over there, whichever you are going to explore, and press shift plus tab. Okay, and you can explore, and then you can see regressor underscore model dot fit. You have to provide X value, you have to provide Y value, and this is the fit linear models, and this is the parameters X and Y, sample weight, and your returns. This is your result, right? So returns and instant of cell, and this is the method, the parameters, that version 0.17, each sample, individual weights for each sample. So enter definition, how we can use that, what is that originality, everything is given. So just press Shift plus tab. Now we have to feed the data. In order to feed, we have to provide two parameters. I already told, X train, comma, Y train. And you have fit this model X train and Y train, because X train is your what? What is your X train? Tell me. Dependent variable training. And X represent, I already told, X represent your independent, sorry. X is your independent, Y train is your dependent. So feed the data on the training set, not testing. Please remember, we have to train the model and the training data set. 70%. So dependent variable, independent variable. X is independent, X is your independent, Y is your dependent, right? X is your independent, Y is your dependent variable. And now we have to model, feed the model. Now our model is now how we can see how we can predict. Now we can predict the data training and test. We can predict the data, right? How we can predict? That is your same regressor model dot predict. You have to predict it. So something you have to provide, that something is your test, X underscore test, and you just assign in one variable, that is your Y underscore predict. Y underscore predict is your prediction, right? And you just press Shift tab, predict. And you can see, just explore, and signature is regressor model dot predict. Predict using the linear model X array like or sparse matrix n sample. So matrix value you have to provide text value, and it returns this file. This is the file and the time. Okay. And just press Ctrl Enter. You have to make the prediction and also print the Y. Just write print Y underscore. And you can see model prediction. They've given the value, right? And if I want to interested to see 5 data, only 5 rows, then also they have provided the 5 data. 1, 2, 3, 4, 5. So they have provided the training testing data set after prediction, but only 5 rows I am going to see interested. Okay. So prediction also done, and one more thing, that is your after prediction, find the root mean square error. You have to input sklearn dot matrix, and you have to input mean square error. Mean square SQU mean squared error. Yeah. And you have to write np dot sqrt and you have to provide the mean square error. Just copy the mean square value. Mean square error. And you have to provide y-test and y-print. So just provide y-test is already there and y-print is we already created this value and square root we create. So this is your root square value. Okay, so just write print is the print and you can also create a string and also write or I just the root in okay, some problem I think. Now we have to yes. So just problem was some spacing and value is done. And now up to that we have to create that model, we have to predict the value, we have to test. Now one question in my mind that in latter use case, like if I'm going to create that API or if I'm going to create the web application, that time we require this model. So Jupyter Notebook only create the calculation parts, right? But we anyhow we have to extract, we have to export the model. My model is done, but I don't how to export the model. Okay, so if you export the model and you also use the prediction and also use the reusability purpose that export the model. You have to create your APIs, you have to create the web application with that model. Okay, so how we can export the model? Just this is not inside this task. I just create for my interest, own interest. So just take the markdown cell and you can write how to export the model. Same concept in every project, a linear regression, recent tree, logistic regression, everywhere. the same concept, how to export the model. So in order to export the model, we have one concept that is you have to use the job link. Okay, just write, just go to the official documentation and that write job link. And this is the official documentation page that running Python function as pipeline jobs. Okay, so uh, here the documentation is given how we can use that job lib and how to evaluate and how we can load the model, how to create the APIs. So everything they have given. So if you want to explore, so this is that official website. That link I also provide to that my comment section, your description box. So you can get and explore these things. But here I am going to show that how can export the model with that help of job link. So in order to export the model, na, you need one thing that is you have to import the job link. The first task that you have to import the job link, and you have to prediction will be created, and you have to export that model. So just go over there and you have to export the model. Just write. First, you have to import your job lib. Your job lib. Okay. My job lib import is done. Now I have to save the train model. Use that save the trained model to a file using job lib. Okay. How we can do that? Just copy the job lib dot down. Okay. And where is your model? Your model is your regression model, right? This is your model. Just copy the regression model and add over there, and you have to provide some name. So we can use that, right? So I'm just write regressor underscore model save dot job. Okay, and you have to dump and press Ctrl Enter. And you can see regressor model underscore save dot job lib. So in your Jupyter notebook where all the folders and files are present, here you can see this one file. So just go and you can see, yes, regressor model seconds ago. You can see seconds ago, 568 beta. So regressor underscore model dot save to your job lib. Okay. So your model is saved. So you can use in that latter part. Now, latter use case, we can use that model. And now I am want to test that's this is the same model or not, and how we, with that model we can test the data. Okay. So in order to also write these things. So to letter, you can also write to letter use this saved model for predictions. Okay, for predictions. You can load it back. You can load it back into your code, into your like this. So how to doubly just sorry working job lib dot load. and identify the file name. Simple. Regression model save there, and you have this loaded your model. So just write load. Okay, so you can write loaded regression underscore model is equal to load, because same path. You have to basically here you have to provide a path. Basically inside the bracket you have to provide the path. Same. I don't have any other things. So joblib dot load and your model will be loaded. Your model. Now I am going to test. I am going to predict. So same result I am expecting. Okay. This result I am expecting from the loaded model. Now I am going to predict not the real this model, exported model, right? So here I am going to write now you can use loaded regression model for prediction. So we can write for predictions. So we write predictions is equal to how we can predict the loaded regression model. Predict number. Just write x test, x underscore test. Okay. Let's see. My prediction also done, and I am expecting the same result. Okay. So print predictions and 5 rows. I'm going to see. Let's see. And now you can see exact result. That means exporting the model and testing the model is done. You can see earlier we done y underscore pred and 5 rows, and that the model, regression model. And now we can see there's prediction with my exported model. For prediction with my exported model. Okay. Now we can understood, right? How we can export, how we can import, and how we can use the job lib. That is basic, very basic thing that I have explored the job lib. So now let's move to the next part. That is your linear regression is done. And now I have to use that logistic regression. Okay, linear regression we have done. Now I'm going to use the logistic regression. Just copy. Now I'm going to create that logistic regression. So just copy the logistic regression, this value, and just go over there and just change and logistic regression part. Okay. I hope you can understood the linear regression, model building, regression model that is done. From here we have started linear regression, just copy. And now have to paste and logistic. Just change it to regression. Here we can see dependent variable is change, here's churn, and independent variable is monthly charges, right? In the logistic regression. So just copy these questions and you can write in that next tab. Here, dependent, please remember dependent variable is churn and independent variable is monthly charges. So you have to take the customer underscore churn. This is my data. It's churn. So monthly charges. Independent variable. Yes, so customer, our independent variable is what? Monthly charge, and that should be your X value. Obviously, just copy monthly charges, and here you have to take Y value, that is your customer churn. This is the main data, na? Just copy and paste and change that. So we have chart. Copy the chart and add it. And this is your dependent variable. This is your dependent variable. Okay. We can also see the X data, see the Y monthly charges. Okay, and this is the data. X, X, underscore data. Same thing if I want to print my Y data, also type also my Y. Okay, so this data you can see 0, 1, no, yes, this data, right? Chart or no, yes or no? So my target is my target, this is my target. Target is my churn column. Okay. So now I'm going to understand the customer is churn or not on the basis of monthly charges. Monthly charges, the customer is churn or not. And first you have to split it. Once you can just go and you can copy this. So split the 10 test. Simply just change the ratios. Okay. Just write split the 10 test setup. We can split the and each data, and this time test size is 35. Great. Divide the data set in 65 into 30 is to 30 this ratio. 65 is to 30. 5 test size is 35. So 30% the record would be test size and 65% will be your training data. And all the data we have been storing your extend, X test, Y test, and Y test. Now you can also take the same way. You just write X underscore train, say Y X X underscore test dot save Y underscore dot save Y underscore test. Okay, this is your data set. 65% and 35%. Now we have to create the logistic regression. So you have to import. So you can write in your model. Just to go and just write sklearn logistic regression. So go to this documentation, sklearn.linear model logistic regression. This link I also shared with you in the document section. So you can see you have to import the logistic regression. Just copy this line, copy, and I have to add this logistic regression one. Okay. Good. And now what we have to do, we have to initialize the construct of the model. So this is my log model is equal to what? Logistic regression. Logistic regression. This time you have to copy this line and you have to provide unique the model construct for logistic regression. Okay, so your log model is created. Okay, so entire process is very easy with the help of sklearn libraries and dependent variables. That independent variable we are going to add in the log model, and you have to create the model and build the model. Okay, and you have to find out the metrics of confusion matrix, accuracy score of the all the things you are going to provide. Okay, so they have told you build the confusion matrix and get the accuracy score. Okay, so just write log model. What value we should prepare? Extend and you find. So Switch the model. Now we can switch the model on top of training data on top of my training data. Okay, and your model, logistic regression model is done. Okay. You can also shift tab, or you can also shift tab over here, na? Logistic regression shift tab. So this is that initial. You can see these all the parameters, and you can see these all the parameters that is used in the logistic regression. The init signature. So multi-class, random state, class weight, everything. Okay, and the doc string, they have also given the classifier archaeologist maxed int for that logistic regression model. So in the multi-class case, the training algo uses the one versus rest OVR. So you can explore the doc string. So everything is given, just press shift plus enter, and you have to get the this documentation part. This is the inbuilt documentation, and you can also click on that new tab. It is also creating. Just in the new other tab, this logistic regression and this documentation will be provided. Right? You can see what is the attributes. You can see. You can see the attributes, the classes, coefficient, intercept, and also that you can see that references, example, how you can use. Everything is inbuilt over there. Just explore the things. Okay. Just just open the notepad. Let's say X understood these things like Y is equal. You have X1, just understood the concept X1, X2, X3 plus X4, right? So this is the simple. Okay, in the multiple area regression, we have multiples, and we're trying to understand what is the prediction and why the relationship of the y and x over there, right? So this is the simple concept that we know, and we have to build the model. Now we can build the model on top of training set. Okay, so log model dot predict. So we have multiple x values over there, and we have to predict. We have multiple independence variable over here, okay? And we are trying to understand how this multiple independent variable going to adding over here, okay? Trying to understand this concept. X plus what? Test. And assign it y bread. Y underscore bread. So when it comes to the classification model, so we repeatedly explore the confusion matrix. So just print can also check the Y-braid value. Y-braid, that is your value. You can also check. No. Okay. Now confusion matrix. Let's check the confusion matrix. Now we can create confusion matrix and accuracies. So same, we have to input something. We have to input the scalar. Only one stops off, that is scalar model. Everything is there. So you can also just go and input from sklearn. Okay, dot matrix. We have to import confusion matrix, and you have to input accuracies. Okay, so you can also just basic tab. First have to import this one. Import this one. Is from your main class is scalar, and the from matrix you have to import. So you have that confusion, just import that confusion matrix. We have already import, and now we can use that. Now we can use that confusion matrix, and you have y test, and you have y rate. So confusion matrix, we can see this is the value of your confusion matrix, and we have to create the accuracy score. Just confusion matrix. Now we can create. Accuracies. How can we do that? Just create the accuracy score over there. In order to create accuracy score, just paste, and you have to provide two values: y test and y print. Y test and y. For the classification, we need classification. We need and accuracy. Okay. So let's see what's my accuracy score of this logistic regression model. And this is the accuracy score. And this predicted classification of the confusion matrix in So you can see that confusion matrix, true positive and true negative, these values are the concept I have not discussed, and it in the other session that everything I've discussed all the things. Now just explore the confusion matrix and accuracy score. Okay, and you can see that why negative value, positive value is there. This is the negative one, and the positive one that I'm going to add it. Okay. Now you have to one more task, build multiple logistic regression. You have to build multiple logistic regression. Just copy, explore the task first, and the concept, all the things, don't worry, we are going to discuss the separate videos. All the things are there. and just explore that how we can use that in that projects, right? So build a multiple linear regression model now where dependent variable is your churn, independent variable are tenure. Multiple independent variable. You can see two independent variables and only target column is one churn, and independent is tenure and monthly charges, right? Let's explore these things. No issues. That we will add. We have two independent variable and one dependent variable. We have the multiple independent variable. And now my independent variable are monthly charges and tenure. So this is the column customer underscore churn. This is your data. And same thing, just don't worry, no issues. I just copy this line. No? Just copy this line and add wire. Same thing. Only add this tenure. Complete. Yeah, this is your two independent variable, one dependent variable. Okay. And trying to understand customer are churn or not on the basis of two dependent variable, monthly charges and tenure. And y is the same, x is two independent variable. Just initialized that x and y. Okay, by x values is given, y is also given. So you can also explore the x, also get the value x. Okay, now we can see two columns are coming, monthly charges and tenure. Earlier, when we explore that time, it only show monthly charges because only one variable is there. And now I have two independent variables. That is one monthly charges and it is one tenure. Okay, we can print this one and we have to create the same test. Okay, so your 10 test spread you have to do. No issues, same thing, just copy this line. Everything you have done, just copy this block instead of line. Okay, and just paste over there. And this time your 10 test divide the data set is 80 into 20, no issues. Just write it 20. So 20% my test data and training data is my 80%. And up to with the model 80 into 20. Yes, copy 80 and 20 ratio. No issues. You just done. You also want to check the shape. Everything is same. No, there is no changes. Okay. Everything is same. So you have to explore these things. Extend and shape. And you have to predict the value. So earlier, this same thing is done, na? You predict the value. Logistic regression is there. Just copy and execute the new cell. Otherwise, this value will be over updated. No issues. While create block model dot predict and you have this while create. These are coming. Access to features per sample expecting one. Okay, so I to just just add this one. Logistic regression is created. Yes, it's value. I done this yesterday. Model still model. Model is done. Now this time we can predict. Model dot predict. Model dot predict, right? We can also do these things. Copy the line and over there, and you have this prediction value. And y predict will take y square predict, and then prediction is done, right? And I have to create same thing, confusion matrix we have to create. This is already input, just copy confusion matrix. This time the value will be changed. Definitely the value will be changed. Let's take a look on the confusion matrix. You can see confusion matrix data also here, and also accuracy score. Go and okay, and this time you can see 77% accuracy score is given. And you can see you can check this way manually also. 34 plus 156 y. You can also write 935 plus 156 plus 107. And same accuracy, you can see. It's a manual calculation, accuracy score. Okay. So this is manually we can create the accuracy score. So left diagonal is already classified, and these values are misclassified, right? True positive, true negative, this concept. Now our logistic regression part is done. And same way you can export this model that just I already shown, right? And you have to input job leave and you can run this model You have to predict this one. The concept is same, just change these values and job loop done. You have the logistic model. Just copy this line, just adding this one, and this time last model that I'm exploring. This is the value tone regression model, and that time it should be your not the confusion matrix. That is your log model. So just do one thing. Minute. 1 minute, 1 minute. So I have to add this one. So just copy the log model and just scroll down and model. Just change the name. Log model save should be there. Yes, you can see log model log underscore model underscore save, and that is created. No issues. Sorry. You have to import this model, load your model, right?